Hi guys, I am Arpan Mukherjee, a class 12 pass student. I have no idea about opening this channel, but I got this idea from one of my friends, and also most of the students of my batch come to me for solving organic chemistry problems. So I thought to open a channel for them that I could explain organic facts. But today, as it is first episode, I am going to elaborate about common ion effect, very important for class 2 level students, but very easy concept. So we may get started. And one thing, if you like my effort, so please drop a like to this video and subs to my channel for upcoming videos. And please, I will soon bring some organic episodes for you guys. So please subscribe to show some support for this channel. Now we can get started. Suppose in a solution we have added a weak electrolyte X, the arbitrary compound X, which dissociates like this. As X is weak electrolyte, it will form equilibrium. So I have used a double-headed arrow. Don't forget to use a double-headed arrow because it is very important. In this solution, a strong electrolyte Bx is added. As this is strong electrolyte, we will use a single headed arrow. Mind it, this is very important. Then X minus is common ion. You can see that. According to common ion effect, we know that the dissociation of weak electrolyte will decrease. So X, the dissociation of X will decrease. Suppose at first C mole of Ax was present in solution. So X, writing it again, A plus plus X minus at equal to 0, it has C, 0, 0, at equal to T, C into 1 minus alpha, C alpha, C alpha, where alpha is fraction of dissociation, alpha is so dissociation constant K equals to A plus into X minus concentration of X minus by concentration of X is equals to C alpha dot C alpha by C into 1 minus alpha. So we get C alpha square by 1 minus alpha. Now M mole of Bx is added. Writing Bx as B plus and X minus. So it is M at equal to 0 is 0 0 at equal to T as it is totally dissociated. So M 0 mm. Now we are not going to write K for this equation because we need K for Ax, as dissociation of Kx will decrease. We have to prove, what do we have to prove? That the value of alpha will decrease it, and we have to prove dissociation of Ax will decrease. So we write, suppose fraction of dissociation is X. Is X. Now why we are doing this? You can ask me this question, because we have to prove what are we doing? Common ion effect. We have to prove that for a common ion such as X, the dissociation of a weak electrolyte decreases in presence of a strong electrolyte. So we are doing this. Again, now we can writing it ax double-headed arrow a plus x minus. Now ax now when bx is present in the solution at t equal to 0, x is c, t is 0, and mind it is m, as bx is totally used and x minus is present in the solution, and from total bx m is coming from it. That t equal to t, it is c into 1 minus x, because alpha is changed to x. It is cx and m plus cx. Now division constant k equals to cx dot m plus cx by c into 1 minus x equals to, right, x into 1 plus cx by 1 minus x. Now comparing, it is the number 1 equation and it is the number 2 equation. Comparing 1 and 2, we get, comparing 1 and 2, we get m plus cx by 1 minus x equals to c alpha square by 1 minus alpha. See, you can write now, it is like this, mx by 1 minus x plus cx 1 minus x equals to c alpha square by 1 minus alpha. See, in this case, you may see in the books they have ignored alpha or x with respect to 1, but I haven't ignored them, because we can solve this by ignoring them, but I don't need to. I have to just prove alpha is greater than x. In presence of a strong light bx, the division of ax will decrease. I have to just prove that. So I haven't ignored 1 minus alpha or 1 minus x. I have just give them. So see, now see, cx square by 1 minus x and c alpha square by 1 minus alpha, these are two comparable to parts of this equation. But you see in the left side, we have added a part mx by 1 minus x. This part is the additional part. So you can see, to get these two sides equal, we have to add a part mx by 1 minus x to left side. So we can say cx square by 1 minus x. So cx square by 1 minus x is less than c alpha square by 1 minus alpha. So by this you can write x square by 1 minus x is less than alpha square by 1 minus alpha. From this inequality you can say x is less than alpha, as x and alpha greater than 0. You can write it. So x is less than alpha, hence proved. We have to prove this equation and I have proved it. See, I have to prove x is less than alpha. I have first told you guys. So what I have to prove? I have to prove that division of x will decrease in presence of a strong right bx. The common ion x, while the common ion is x, and see, x is less than alpha. So putting it, if this x is less than alpha, so division of ax will decrease. That the reaction will go to the left side. It will go to the backward reaction. The backward reaction will be spontaneous in this case. Okay. Now, just I am telling it for another time for you guys to repeat it for repetition, that we have added ax in the solution, that are dissociated a plus and x minus. Weak, as it is a weak electrolyte, you will partially dissociate it, and then we have added a strong electrolyte bx of m mole, it will release b plus plus x minus. We have calculated division constant k for ax, and then again comparing with bx, when m mole of x minus present in the solution, we have again calculated division constant for ax, and comparing both of the equations 1 and 2, both of the 1 and 2, we have concluded that x is less than alpha. So this is our common ion effect. So this is it for today. Thank you guys for seeing. Stay tuned for my next video. Thank you. Please subscribe.